So for this lesson, we're going to talk a little bit about Desmos, which you can see in the background there. The Desmos graphing calculator started as a Chrome extension used to visualize graphs and charts. And since then, the scope of equations the software could perform has been expanded. And it's actually kind of neat in a lot of ways. For instance, if you're typing an equation, say like y equal to 3, as you're typing it, you can see that it has been the graph is created as you're typing, and as I add stuff to it, the graph changes. So let's go ahead and look at some questions and kind of see some of the potential you can do, the types of things you can do with it. So for the first example, let's go to Desmos, and the website there is desmos.com/calculator. And enter y equals mx plus b, add sliders for m and b. So and what you can do is just type it just like that, y equals mx plus b. And you see below that it asks you to add sliders for the m and b. And if I do that, there's an equation. And you can see that as I change m, you can see that the slope of this line keeps changing based on whatever m is. And the b moves the line up and down. Now, if I add a point, let's go right here, parentheses, 0. Let's clear this. There we go. Clear this. All right, here we go. Try this again. If I go parentheses, 0, comma, b, and click on label, you can see that that point is now highlighted, and as I change the graph, you can see that that 0b is the y-intercept, and it's the same value. It starts at x is 0, and the y value is the same as your b. So if our b becomes negative 4.8, the y-intercept is at 0, negative 4.8. So in terms of what effect the graphs have, the m basically changes the slope. So as I shift the slope, as I change m, slide it back and forth, that changes the slope. And the b basically changes the y-intercept, which is what we expect since y equals mx plus b is the slope-intercept form of a line. Okay, so let's try this again. Let's clear these off. Let's try y equals ax squared. So I go y equal to ax and then exponent 2. And I want to add a slider for a. So what you have here is a shape, kind of a U shape that we call a parabola. So what does a do? Well, if I make a larger, so if I slide to the right, you can see that this graph becomes more and more narrow. And if I shift to the left, it becomes wider and wider to a point where if I hit a equals 0, it's a horizontal line. And if I keep going negative, it's now below the x-axis. It's opening downwards, upside down U. So the A basically tells you whether you're above or below and kind of how wide. So that's the effect of the A here. Okay. Well, let's go back to lines, and let's say I want to find the intercepts to the equation y minus 5 equals negative 5/14 times x minus 14. So if I go y minus 5 equals negative 5 over 14, x minus 14, I have the line, and I may need to shift this over a little bit, but what happens is the y-intercept and the x-intercept are kind of always highlighted. So I can see that as far as the intercepts go, the y-intercept is going to occur when y is equal to 10, and the x-intercept is going to occur when x is 28. Okay, and so those were the two intercepts. Let's say, next question here, Find the x-intercept of the line with slope 4/3 and point 1824. So if you recall, the point slope form is that it's y minus the y value equal to the slope times x minus x value. So that's going to become y minus 24 is equal to 4/3 times x minus 18. So let's type that in. We can type it in just like that. Y minus 24 equals 4/3 x minus 18. And from the looks of it, well, it looks like the x-intercept is right at the origin, 0, 0. So what is the x-intercept? It looks like the x-intercept is 0. Simple enough. If I kind of zoom out a little bit, or I guess that's enough. If I plot the point 1824, that should be on the line. And you can see there is 1824. So the line does go through it, and it looks like it has slopes 4/3, and the x-intercept is at the origin. Okay. How about an intersection? So where do the lines y equals 2x minus 5 and 15 minus 2x intersect? So let's just type this up. Y equal to 2x minus 5, y equal to 15 minus 2x. And it'll the graphs, the intercepts of the graphs will highlight, so I can know there's the intercept right there at 0, 15 and 7.50. And if I click on the other line, I can get the x and y intercepts there. But it also shows the intersection, which occurs at 5, 5. So where do these lines intersect? Well, at the point 5, 5. So when x is 5, y is 5, that's the intersection. That's a point in common with both lines. All right, let's try something a little more complicated. Where did the graphs of y equals 7 minus x and x minus 1 squared intersect? So again, if I type y equal to 7 minus x, okay, and then if I type y equal to x minus 1 squared, and I can go ahead and zoom in a little bit, you can see that there's an intersection right there at negative 2, 9, and another one at 3, 4. So the graphs intersect at negative 2, 9 and at 3, 4. So there are two places where these two graphs intersect. All right, another thing you can do is quickly find function values. So let's say y is equal to x squared plus x plus 1. So y equal to x squared plus x plus 1. And I see I have a graph. Again, it looks like what's called a parabola. If I click on the setting wheel here, edit list, you see there's this little option for this create table. And a table is created below that. And this is where I can enter different x values. Say if I enter the x value of 4, you can see the y value is 21. If I enter x value of 1.5, I get 4.75. If I enter x equals negative 3, I get 7. So the answer to the question, find the value of y when x equals 4. From the table, y is equal to 21. If x is 1.5, y is equal to 4.75. And if x is negative 3, y is equal to 7. Right. What if we want to graph, say, just try graphing x squared, x to the 4th, and x to the 8th, and see what they have in common. So y equals x squared y equals x to the 4th, and y equal to x to the 8th. And you can see these all have this. By the way, if you click on these little icons on the left, you can hide them or show you those graphs. So there's y equals x squared right there, y equals x to the 4th, and y equals x to the 8th. And you can see that they all have this kind of U shape to them. But it's also, as that exponent gets larger and larger, you can see they get more and more narrow. So in terms of what they have in common, they all have this U shape to them. Now what about x cubed, x to the 5th, and x to the 9th? So y equals x to the 3rd, y equals x to the 5th, y equals x to the 9th. Now in this case, if I'm looking at the graphs one by one, there's x to the 3rd, x to the 5th, and x to the 9th. And what they have all in common is they have this S shape to them. They go up really quickly on the right side, they go down really quickly on the left side. So basically x to an even number is sort of a U shape, x to an odd number is more of an S shape. And finally, let's try to do a series of graphs. Let's see what happens. So let's say I want to draw x squared plus y squared equals 36. So x squared plus y squared equals 36. Okay, let's go ahead and center that. All right, so that's that one. The next one is negative square root, SQRT can do square root, 9 minus x squared minus 1. Okay. And then the next one was x plus 3 squared plus y minus 2 squared equal to 1/4. And let's see here, if I go here and copy this and change this last one to minus, there is the graph. And let's clear off I can clear off the grid and the axes. And, well, have a nice day.